Assalamualaikum and hi everyone. Welcome to my video chapter 1 vector calculus new subtopic 1.5 line integral. Line integral is the integral of the function f(x,y) that is evaluated along the curve C. Line integral can be evaluated in two types of field. First is scalar field. For example, if the fx is the density, then the line integral give you the mass. Okay, for the vector field, you can obtain the amount of work done on a particle that move along the curve C. Okay, the most basic concept of line integral is the integration of a vector field along a curve. Okay, simple integration can give you area under the graph. Okay, let's say we have the function fx. Okay, we integrate the function of fx from a to b. Okay, then you can get area under the graph. Okay, this is the integration to find area under the graph. Okay, next for the line integral, can you see the curve C? Okay, it is called part of integration from A to B. This one, A to B. Okay, line integral will give you area above this curve and under function f(x,y). And let's see definition 1.17. Okay, a line integral of a vector f over a curve C where C is represented by RT is defined by this formula. Integrate f dot dr. Okay, this is dot product. Okay, just substitute f and dr, then you will get the dot product equal to this or this one. Okay, let's see definition 1.17. Okay, a line integral of a vector f over a curve C where C is represented by RT is defined by this formula. Okay, integrate f dot dr and this is dot product. Okay, just substitute f and dr, then you will get the dot product equal to this one or this one. Okay, to solve the line integral, you have two main steps. Okay, first step is identify the category of the curve and its parametric equation. Okay, when you read the question given, you have to know what type of curve. Okay, basically, we want to represent curve C by RT. Okay, look at this table. We have different types of curve. And for the second column is parameterization of parametric equation. Okay, so for example, you have x equal to y. So when you parameterize it, you will get y equal to t. So x equal to t. Okay, just substitute t in y. Okay. Let's say we have another equation which is y equal to e to the power of 2x. You have to parameterize it by represent x equal to t. So y equal to e to the power of 2t. Okay, remember that based on the question and equation given, you have to parameterize it based on the curve given. Okay, this is the standard equation for circle and ellipse. So when you need to parameterize the circle equation, you just parameterize it like this, and for ellipse is like this one. Okay, last one is the line segment from one point to another point. Okay, if you have 2 points of line segment, you have to parameterize it using this equation. Okay, why we have to parameterize the equation? Okay, the reason is we want to do the single integration only. A single integration only. So, to do the single integration, you have to make sure that the equation has only one variable. Okay, for example, x, y, theta. Only one variable. So, make sure if you have function in x, y, z, you have to parameterize it first to convert it to one variable only. After you parameterize the equation in step 1, you can continue to the step 2 to solve the problem. Okay, from step 1, you have to write the equation in the form of RT, which is RT equal to XTI plus YTJ plus ZTK. Okay, next you need substitute xt, yt and zt into vector function f that is given in the question. Then you need to find the r, which is you differentiate rt. Okay, then you combine f and dr using dot product. So you have to remember when you apply the dot product, you will get the scalar function. Next, you have to integrate it, but you need to find the limit of integration. Let's see example 1.15. Calculate integration of f dot dr. So this is the formula of line integral. Given f equal to xy and rt equal to t squared t3 from 0.48 to 0.927. To find the line integral, we need to follow the step. So for the first step, we need to find dr. Second step, we need to find ft. Third step, you need to find the limit of integration. And for the fourth step, you need to integrate. Okay. First step, you need to find dr. So in order to find the dr, you need to find r. So for this question, rt is given. Rt equal to t squared t cube. So dr dt equal to 2t 3t squared. So we want dr. So we just bring dt to the right side. Okay. From rt, we can find the value of x and y. So x here is t squared and y is t cube. So xt equal to t squared, yt equal to t cube. Okay, step number 2, you need to find ft. Okay, we know that f equal to x, y. Vector of To find vector of x, y, we need to find ft. Okay, we need to change x, y to t. Okay, from step 1, we know that x equal to t squared and y equal to t cube. Okay, for the third step, we need to find limit t naught to t1. So we use the point given, which is t naught to t1. So at point 4a, t squared equal to 4 and t cube equal to 8. So we can get t naught equal to 2. From the second point at 9:27, t squared equal to 9 and t cube equal to 27. So we know that t1 equal to 3. For the fourth step, we need to integrate. So we integrate using the formula of line integral. So we integrate 2 to 3. Just substitute f, where f here is t squared t cube. So t squared t cube dot dt. dt here equal to this one, 2t 3t squared. So we need to solve the dot product first. So multiply with the same component, we will get 2t squared, so 2t cube plus 3t to the power of 5 dt. So you integrate From limit 2 to 3, you will get 2t to the power of 4 over 4 plus 3t to the power of 6 over 6, limit 2 to 3. So when you solve it, you will get 405 minus 40. So the final answer is 365. Let's move to example 1.16. Evaluate the integration of f dot dr. So this is the line integral, where fxy equal to negative yx along y equal to x squared minus 2 from the point 0, negative 2 to point 2, 2. Okay, so the curve may be something like this. Okay, the particle move from point 0, negative 2 to point 2, 2. So we need to find the work done move along the line y equal to x squared minus 2. So we write the formula of line integral. So first step, we need to find dr. So before we find dr, we need to find the rt. Second step, we need to find ft. Third step, we need to find the limit t0 to t1 before we integrate it. So for this question, rt is not given. So you need to calculate rt. Okay. From previous lesson, you have learned about parameterization of the equation. So for this question, you are given y equal to x squared minus 2. So when we parameterize the equation, x equal to t, so y equal to t squared minus 2. So from this information, we know that rt equal to t squared minus 2. So we can get the dr dt. So differentiate t, we will get 1. Differentiate t squared minus 2, we will get 2t. So dr equal to 1 2t dt. Step number 2, we need to find ft. From the question, you know that f equal to negative yx. So you can use this information. Okay, ft equal to negative y. So y here is t squared minus 2 and x equal to t. So you just simplify it, you will get 2 minus t squared. That we need to find the limit of integration t0 to t1. So the curve of this equation is like this, from point 0, negative 2 to 0.22. So this limit is based on this 2 point. So how we want to determine which one is the limit between these 2 points? Okay, let me tell you. Remember what we have learned in the first step, parameterization, which is in the step 2. Okay, we know that x equal to t. Based on this information, the limit is based on point x. So the particle move from 0 to 2 because we want to integrate in the point of x. So for the step 4, we just substitute f dot dr. So f here is 2 minus t squared t dot dr here is 1 to t dt. So before we integrate it, we need to solve the dot product. So we will get 2 minus t squared plus 2t squared. When we solve it, we will get 2 plus t squared. So we can integrate it limit from 0 to 2. We will get 2t plus t cubed over 3 limit 0 to 2. So when we solve it, we will get 4 plus 8 over 3. So the answer is 20 over 3.